This is Saxon Math for 6th grade. Today we're doing lesson 100. Lots of notes to take today. Lots of things to remember, but nothing difficult, I promise. We're going to talk today about estimating square roots, estimating, not solving, and irrational numbers. Let's start at the top here. This is our estimating square roots section of notes. And these are things that you already know. Make sure you write them down so you remember. 2 squared is 4. Whenever we take the square root, we're doing the reverse of squaring it. So 2 squared is 4. Then the square root of 4 is 2. 3 squared is 9. So the square root of 9 is 3. 4 squared is 16. So the square root of 16 would be 4. 5 squared is 25. So the square root of 25 would be 5. Today, they're going to ask you to think about a square root that you don't know yet. So for example, we know the square root of 4. We know that's 2. We know that 2 squared is 4. So the square root of 4 will be 2. We know the square root of 9. We know that 3 squared is 9. So we know the square root of 9 is 3. What if they asked you about the square root of 5? 5 is bigger than 4, so my answer would probably be bigger than 2. And 5 is smaller than 9, so my answer would probably be smaller than 3. Today, when they ask you to find which whole numbers it's between, we don't actually want you to solve. They just want you to recognize that the square root of 5 has to be bigger than 2 because it's larger than 4. And it has to be smaller than our 3 because it's smaller than 9. So our answer is going to be between 2 and 3. Similarly, if they gave you the square root of 16, you would know that that was 4. And if they gave you the square root of 25, you would know that that was 5. What if they asked you for the square root of 20? What 2 numbers would that be between? Well, 20 is bigger than 16 and smaller than 25. So the answer must be bigger than 4 and smaller than 5. It would be between 4 and 5. That's all you're doing today. You're just estimating. The square root is between what 2 perfect squares? All right, now for my lovely picture. Most of this is review. Make sure you put it on your paper. We haven't drawn it this way before. At the very beginning of the year, we started learning about counting numbers. These are the numbers you use when you count. When we count, we always start at 1. We don't usually count no people. If I say, how many people are in line? The first person says 1, and we keep counting. Counting numbers start at 1, and they're whole values. If I was counting the number of people in line, I wouldn't count half of a person. There wouldn't be half a person. There'd be whole people all the way up. Whole numbers are the same as counting numbers. They include the counting numbers. See how it's inside the same square? Counting numbers are inside the whole number square. But they also include 0. 0 is a whole number. Next this year, we learned about integers. Integers is just kind of a fun word to say. Notice that the integer square includes inside of it the whole numbers and the counting numbers. Integers are whole values, but they can be positive or negative. Integers. Here come our new names today. Rational numbers and irrational numbers. The trick to remembering this is to look at the word. Rational numbers can be in ratio to each other. Rational numbers are any number that you can write as a fraction. Doesn't matter what the fraction looks like. As long as it can be a fraction, any kind of fraction, it works. So 1/2, 1/6, 7/3. As long as it's a fraction, it works. Repeating decimals would go here too. Like 0.3 repeating, that's a rational number because 0.3 repeating is actually the same as 1/3. Rational numbers. Integers are part of rational numbers. Whole numbers are part of rational numbers, and counting numbers are part of rational numbers. These sort of fill in the spaces between the numbers on the number line, if you will. Now comes our new thing. It's the only box that's separate. These numbers are not counting numbers. They're not whole numbers. They're not integers. They're not rational numbers. They're not in the same container. These ones are their own creatures. They're called irrational numbers. Ir means not. So these are not rational numbers. They will not go in ratio. These are numbers you cannot put as a fraction. They cannot be repeating decimals. There's not very many of these numbers, thankfully. One example would be pi. Remember, pi goes on forever. 3.1415, etc., etc., etc. The square root of 2 is an irrational number. It would go here as well. Both the rational numbers, all of these, and the irrational numbers are considered to be real numbers. They're numbers that exist and that we see in the real world. When you solve your problems today, make sure that you look for what square roots you do know to help you solve which two answers it will be between. And when you're looking at rational numbers, look to see whether it can be represented as a fraction or whether it cannot be represented.